Hi students, let's look at this question here, which was actually taken from the year 2014 from the NJC, and it's taken from the prelim paper, paper 2, question 3, and this question is on complex number. Okay, it's a pretty interesting question here. So you're asked to find the what do you call it, z from this equation here at a glance, and x plus yi. Now, I think one of the main methods students would like to use is to replace it in and try and solve it afterwards, but I think that will be actually quite a waste of time. I think I can foresee that actually will cause a lot of workings there, but I'm not going to do that. So I'm going to use if you could see properly, modulus of whatever complex number it is within here, this will yield a real number, right? So this is a real number. This will yield a real number. So what I could do is actually I could just compare the imaginary and the real parts on both sides, just like that. Okay, so for a start, I'm just gonna copy the equation down. So I'm just gonna let basically, since okay, maybe it's a bit too I'm just gonna let a1 minus z conjugate z minus 1 squared equals to a, where this is a real number lah. Okay, so where a is a real number, I think this will be easier to see. So what you could do is actually this will be reduced to a minus z equals to I. Okay, now you can't compare coefficients, you can't compare the imaginary and the real part now, because z contains imaginary parts. So the only way to compare is when this is entirely, like, you know, when it's entirely broken down to the imaginary and the real part. So what I'm gonna do is I'm gonna substitute z equals to x plus yi, right? This is 1. So here we're gonna get a minus x plus yi equals to I, and we're gonna get x minus 1i equals to I. There you go. This is pretty okay. So I'm just gonna compare the real and imaginary parts. Okay, that's pretty okay. So here what we're going to get is actually a minus x equals to 0, because this is 0 plus I. So this part here, let me show you, this is equals to this one over here. All right, and then you have got say this minus 1 equals to minus y equals to 1. So that's pretty okay. Once you get that, you just you get minus y equals to 1. So y is equals to minus 1. All right, so that's okay. Now then after that, you try and solve basically now, because z is equals to x plus yi, so you could actually just use this expression here and continue moving downwards lah. So a is actually that whole gibberish there, which is actually 2i minus z conjugate, which is x minus yi, over x plus yi minus 1 square minus x equals to 0. Okay, so this is what I'm going to do. Basically, I'm just going to try and simplify this and see whether I'll get answer. So y is actually minus 1, negative 1. So you could actually just simplify it. So this would be x plus I, and this would be x minus I. Just make it a common denominator here, minus I. This is x minus I, and mod it, this will be x over the other side. All right, so I'm just gonna try and solve this. This is 2i minus I plus I, so it's 2i minus 2x, and this is actually just x minus I. 2 can actually just factorize it out, plus I minus, yeah, so I could factorize the 2 out. Maybe I shouldn't, this is what I get. So this will be 2. Maybe I factorize the minus 2 out, so that I could cancel the x minus I here. Pretty convenient. Okay, so this case here will be modulus square equals to x. cancel it out, cancel, and we're left with x equals to mod 2 square, which is actually 4. So z equals to x plus yi would just be z equals to 4 minus I. That's the answer, I guess. Alright, so that's how we solve this part here. Okay, so this is how we solve the first part. Now let's look at the part B. Part B is a pretty interesting one. I always tell my students, whenever you see expression like you see root 3 and 1, means you could find the exact argument, and similarly with minus 4i. So what I'm going to do is actually, you're asked to find P and Q and REI theta exactly. So I think that is pretty okay. The first part is actually just to draw the Argand diagram if you could not see the argument and whatnot. If you're able to skip this step, is fine also. Anyway, just 2 marks. So to change it to exponential form should be quite a basic concept that you need to know. So basically minus root 3 plus I will be here. This is minus root 3. This is 1 over here, right? So bring it up. This would be this is your P. Minus root 3 plus I. This would be negative root 3 plus I. This would be pi over 6, I believe. So this over here, this is argument. So this argument here would be 5 over 6 pi. Okay. So in other words, if you are talking about this, the modulus is pretty straightforward. It's just 2, right? So just 2 EI 5 over 6 pi. Okay, root 2. Then whereas for Q, this negative 4i would just be here, which is actually just negative 4 here. So this is negative 4i minus pi over 2, imaginary part and real part 0. So Q would just be 4EI negative pi over 2. Alright, so that's okay. So that's the 2 question here. So what we're going to do now is going to do the last part, which is find the exact value of Q10, Q5. Okay, great. So do the first one. So P10 over Q5. This will just be E minus 5 over 6 pi over 4E negative I pi over 2. So this is 10, sorry. The top will be power of 10. So this is 2E I 5 over 6 pi power of 10 over 4E minus I pi over 2 power of 5. Alright, I'm just going to leave it in index form because it's easier. So this is 50 over 6 pi minus 5 over 2 pi. So I think this is okay. So this part here, just key in calculator slowly. This over here, this whole thing here will just give you 1. So this is alright. This is 1. And basically what is left is 65 over 5i. Okay, so this is P10 over Q5. This is it. Whereas if you think about it, Q5 over P10 would just be P10 over Q5, the reciprocal. So this is okay, right? So in other words, this is E minus, this is pi, sorry, pi, and this is minus, okay, basically I'll do it slowly. This is 65 over 5 pi negative 1. So this will give us E minus I 65 pi. Okay. Obviously you need to change it to a principal argument. So 65 over 5 pi just minus 2k pi. Just keep negative minusing 2. This would be 65 over 5 minus 2. Oh, it's actually 13 minus 2 will be 1 pi. Actually just be pi. Well, that's pretty okay. So this is E I pi actually. Okay. Similar with this one. What you're going to get is actually just E I pi E minus I pi. Okay. So from here, what we're going to get is actually just add them up. So this part here EI pi Q 2 minus 4. Okay. Okay, I realize I made a mistake here. 56 minus, this is 65 over 6 here. So sorry. So this would be 65 over 6 minus 2k pi would just be 5 over 6. Okay, so this is 5 over 6 pi. Okay, there's a mistake there. So anyway, this would be 5 over 6 pi, and this will be e minus 5 over 6 pi minus 1. This will be e minus I 5 over 6 pi. Great. Now once you get that ready, what you're going to do is basically just add them up, because these both expression here, they have the same argument, but of different, as in same argument, same modulus, but of different sign. So it's not really, it's something which you should know how to manipulate this. You use the Euler formula. Euler formula would be this. So it's I sine 5 over 6 pi plus cosine negative 5 over 6 pi and plus I sine negative 5 over 6 pi. Okay, so this part here, what you're going to do is actually just going to use the formula cos negative theta equals to cos theta, whereas for your sine theta, this is a given, so sine negative theta is equals to negative sine theta. Okay, so just look it up. Why is it so? This is all is secondary school knowledge, so I'm not gonna to explain here. So here will be just cosine 5 over 6 pi plus I sine 5 over 6 pi plus cosine 5 over 6 pi minus I sine 5 over 6 pi. So what is given is 2 cosine 5 over 6 pi. This is cosine is actually 5 over 6 is actually in the second quadrant, 5 over 6, so it's actually 30 degrees. This would be 2 negative root 3 over 2. So essentially you get a root 3. Okay, so that's how you solve this question proficiently. Any question or comments, please do text me, let me know, okay, in the comment section below, and see you in the next video.